Chapter 6 Application of Derivatives, Exercise 6.3 or 6.5 in the last textbook. Question number 5. Find the absolute maximum value and absolute minimum value of the following functions in the given intervals. In that first question, that is f of x is equal to x cube, where x belongs to the interval minus 2 to 2. So, what is f dash of x? That is d by dx of x cube, that is 3x square. So, at f dash of x is equal to 0, we can write 3x square is equal to 0. From that, x is equal to 0. So, we have the x belongs to the interval minus 2 to 2. So, the values of x will be, in order to find absolute maximum and absolute minimum, it should be minus 2, 0 and 2. It is because it is from the interval minus 2 to 2. So, we will be taking the values of x, that is minus 2, 0 and 2. First, at x equal to minus 2, we have f of x is equal to x cube, or f of minus 2 can be written as minus 2 whole cube, that is minus 8. Now, we will be finding what is at x equal to 0. The next value of x, that is f of 0, that is f of 0 means 0 whole cube. F of x is x cube, so f of 0 is 0 whole cube, that is 0 itself. And at x equal to 2, that is f of 2, which is equal to 2 whole cube, that is 8. So from these we can write at minus 8 we have the absolute minimum. It is the least value in given x equal to minus 2. And at x equal to 2 we have 8, and it is the maximum value we have. So at 8 we have having the absolute maximum value. Second question, that is f of x is equal to sin x plus cos x, where x belongs to the interval 0 to pi. So we have given f of x is equal to sin x plus cos x. So f dash of x is equal to d by dx of sin x plus cos x. That is d by dx of sin x, that is cos x, d by dx of plus cos x, that is minus sin x. So f dash of x is cos x minus sin x. When f dash of x is equal to 0, we can write for cos x minus sin x is equal to 0. By solving, we have cos x is equal to sin x. So in between the interval 0 to pi, we have only one value that can satisfy the condition cos x is equal to sin x, that is at x equal to pi by 4. So the values of x will be 0, pi by 4 and the pi. It is because of the interval 0 to pi. First, when at x equal to 0, we have f of x, that is sin x plus cos x, right? So f of 0, that is sin of 0 plus cos of 0. Sin of 0, 0, cos of 0, 1. So we have f of 0 is 1. At x equal to pi by 4, we have f of pi by 4, that is sin pi by 4 plus cos pi by 4, that is 1 by root 2 plus 1 by root 2, that is by solving it will be root 2. And similarly at x equal to pi, we have f of pi, that is sin pi plus cos pi, that is what is sin pi, that is 0, cos pi is minus 1. So we have f of pi is equal to minus 1. So among these three values we can write root 2 is the greater value and minus 1 is the lesser value. So at minus 1 we have the absolute minimum, and at root 2 we have the absolute maximum. So the absolute maxima value is root 2 and absolute minima value is minus 1. Now moving into the third question, that is f of x is equal to 4x minus half x square, where x belongs to the interval minus 2 to 9 by 2. So we have given f of x is equal to 4x minus half x square. So what is f dash of x? That is d by dx of 4x minus half x square. D by dx of 4x, that is 4 itself, d by dx of half x square, that is minus half into x square, that is 2x. So we have f dash of x, that is 4 minus x. When f dash of x is equal to 0, 4 minus x is equal to 0. From this, x value of x is 4. So we have the interval, that is from x belongs to minus 2 to 9 by 2. So the values of x will be, the three values will be there, that is minus 2, 9 by 2 and 4. So minus 2, 4 and 9 by 2 are the three values of x. So at x equal to minus 2, what is f of x? That is 4x minus half x square. Substituting instead of x minus 2, that is 4 into minus 2 minus half into minus 2 whole square. So by solving 4 into minus 2, that is minus 8, half into minus 2 whole square, that is minus 4. Minus 4 by 2. So we have minus 8 minus 2, that is minus 10. So f of minus 2 is minus 10. Now next value of x, that is at x equal to 4, we have the same equation, that is f of x is equal to 4x minus half x square, that is f of 4 is equal to 4 into 4 minus half into 4 whole square, that is 4 into 4 16 minus half into 4 whole square, that is 8. 16 minus 8 is 8. So now at x equal to 9 by 2, we have f of x is equal to 4x minus half x square. So f of 9 by 2, that is equal to 4 into 9 by 2 minus half into 9 by 2 whole square. By cancelling 4 and 2, we have the remaining 2. So 9 into 2 minus half into, that is 36 by 2 minus 81 by 8. By solving, we have 63 by 8. So we have absolute minimum, that is minus 10, and the absolute maximum, that is 8. 8 is greater than 63 by 8. So at maximum value at x equal to 8 and a minimum value at minus 10. Now moving into the fourth question, that is the last question in this section, that is f of x is equal to x minus 1 whole square plus 3. So f of x is equal to x minus 1 whole square plus 3, where x belongs to the interval minus 3 to 1. So what is f dash of x? That is d by dx of x minus 1 whole square plus 3. That is 2 into x minus 1 into d by dx of x, that is 1 itself. So f dash of x is equal to 2 into x minus 1. When f dash of x is equal to 0, 2 into x minus 1 is equal to 0, or at this time x equal to the value of x is 1. So the values of x will be minus 3. It should be from the interval minus 3 to 1, right? So here we have got x equal to 1. So we have two values for x, that is minus 3 and 1. So at first case, when x is equal to minus 3, we have f of x, that is the question, that is x minus 1 whole square plus 3. So f of 3 will be f of minus 3 will be minus 3 minus 1 whole square plus 3, that is minus 3 minus 1 minus 4 whole square plus 3, that is 16 whole square plus 3, that is 19. At x equal to 1, f of x is equal to, similarly f of 1 minus 1 whole square plus 3, that is 3 itself. So we have 19 is the maximum value, so absolute maximum at 19, that is the absolute maximum value, and 3 is the minimum value, so absolute minimum value is 3.